Hey everyone, Mr. Regan here, and today we are looking at reviewing what we know is happening with our space pod and looking to apply our key concepts to explain and infer what happened as our space pod and space station collided. Now, up to this point, we know a few things. Number one, we know at time one the pod had a medium velocity and more mass than normal as it approached the space station. We know at time two, the thrusters fired with a normal amount of force needed to dock with the station when it had a normal amount of mass. Now, during these lost signals, we were able to infer that because of all these things, the pod collided with the station, causing the pod and station to change their velocity as they moved away from one another at time four. Now, our job is going to be to try to infer about what happened during that collision to cause all of this to happen, how this cause and effect relationship occurred between the pod and the station. So, before we begin explaining that, we got to understand how collisions work. Now, we have two important key concepts that help us understand how collisions happen and work. The first one is the one we just created. When two objects collide, a force is exerted on each object. The two forces are exerted in opposite directions, but the forces are the same strength. And we can see that with our sim example here. We have object A and B, which are colliding here. And when they collide, we see that the forces, those pink arrows, are in the opposite direction, but they're the same force. So what we've created here really is two situations. We have one object, object B, experiencing a force against it, and another object, object A, experiencing a force against it. And if you notice, each of these objects, though different, are experiencing the same force. So we have a key concept that can help explain what would happen when two objects experience the same forces. That key concept says if the same strength force is exerted on two objects, but the objects have different masses, the object with less mass will have a greater change in velocity. So in our sim example here, we have object B experiencing a force of 114 units and object A experiencing a force of 114 units. Both these objects have the same strength force applied in the opposite direction, but they're different masses. Our object B has a mass of 1 kilogram. Our object A has a mass of 20 kilograms. So when we look at this, we can use our key concept to help us explain what would happen to these objects. So we know in a collision, these forces of the same strength would be applied to them. And we know that because their masses are smaller and bigger, we would have different changes in velocity. So let's look at object B. Object B had the smaller mass, and because of that, it had a starting velocity of 3 and an ending velocity of 8. So it changed direction and sped up in the opposite direction. We can see that in our example. Force was applied, sped up in the opposite direction. Small mass, big force. For object A, we see that it has a much larger mass. It went from a starting velocity of -3 to an ending velocity of -2.43. So it slowed down and stayed in the same direction. And we can see that here. Object A is moving away from its original velocity or moving in the same direction, but at a slower velocity. So two objects, smaller mass, larger mass, both have the same force applied to them, but in opposite directions. The lighter object had the greater change in velocity, went from moving in one direction to speeding up and going in the opposite. So, how does this apply to our space pod and space station? Well, your job is going to be to apply these key concepts to what happened at time 3 and time 4. At time 3, that's when we had our collision. So you need to decide what can you infer about the strength and direction of the forces experienced by the pod and station when they collide. So your job is going to be to explain these three ideas. What's going on with the strength, the directions, and the force exerted. Remember, our job is to use our key concept. So we know a force is exerted on each object. The two forces are exerted in the opposite direction, but the exerted forces are the same strength. You need to take this key concept and apply it to what's going on in our comic. In other words, turn our comic into a scientific explanation. Once you've explained time 3, you then need to look at time 4, and you're going to be looking to infer about the velocity of the space station and pod as a result of the force in the collision. So same idea. We're going to use our key concept to explain what's going here. So if the same strength force is exerted on two objects, but they have different masses, the object with less mass will have a greater change in velocity. So we have to infer about what that velocity change is for our space station and our pod as a result of the collision. Again, pulling in this key concept to turn our comic into a scientific explanation. So, folks, that's how we're going to be applying our key concepts to our space station and pod. If you have questions, reach out. Otherwise,